In this video, we're going to discuss the differences and advantages of designing a network with the different types of network designs as discussed in the Cisco book. So the Cisco book really covers three different styles. There's the partial mesh topology, which you can see here has links so that if any one switch goes down, there's a redundant way to get to the rest of the network, but not necessarily the network that's connected directly to that switch. We can go down here, we can see the full mesh topology, which is full redundancy, so if we lose any switch, or if we lose multiple switches, then these switches will still be able to talk, the switches that are still up will still be able to talk to each other, and there won't be any outage, which is very advantageous in today's environments. So the advantage here is you have, basically, you can pretty much guarantee that if you lose one network item such as a router or switch, in this case they're using switches, but you can do this with routers as well. In this situation, you will have 100% uptime. The disadvantage of a full mesh topology is you have to buy extra switches, they cost more money, and it becomes a more expensive option. But if you need to have 24/7 uptime, this is the way to go. If we go back up here to the partial mesh topology, this is generally a good one as you have some redundancy in your network so that you can usually maintain pretty close to 24/7 uptime, but you're not having to pay for extra equipment to create a full partial mesh. Now if we go over here to the star topology, the way the star topology works is we actually have no redundant connections. So you can see that we have star 2, star 3, star 1, and star 4, and 2, 3, and 4 are all connected in the star, but 3, 4, and 2 are not connected to each other. So if one goes down, pretty much, if one goes down, the whole network goes down. So what we're also going to look at in this particular video is we're going to look at the way that the traffic travels around the different topologies, one, and then two, we're going to create breaks in the topology and show how the topology reacts to a break in the network. So we're going to switch to capture mode, or simulation mode, and what we're going to do is we're going to start with the partial mesh topology. So we start with, let's say, PC1, PCM1 or PCM1B send a packet out, and they are trying to send the packet to PM4B. So the packet initially goes out to the switch, and you can see it goes to the two computers on the network, and it is sent across the network. And we'll see here that these two computers, because it sent it out to these two computers, know that they are not receiving the packet, so they ignore it. These two switches go, okay, I know how to get there, so I know how to get to that PC and that MAC address, IP address of PC or PM4B. And so we'll go to the next hop, and what happens is the network so those switches send it out, it floods it out all the ports. And then all of the computers say, okay, so these computers say, I don't need this, I'm not this, and it automatically ignores it. Well, this switch goes, okay, I know where both of those packets go, because they came from 2 and from 3. And so it goes, all right, so I have 2 packets, so it then sends them to we'll hit forward here, and it sends them out to those 2 computers, and then that's the end. And those 2 computers have now gotten them. So one thing I do want to point out is in this network, with having partial mesh, you also want to have spanning tree topology, or spanning tree protocol enabled, which is what is here. So basically what happens is, in this particular case, spanning tree kicks in and says, alright, so I have a redundant connection here and here, I'm going to close this connection down, basically drop a tree over the line, so that when the packets get sent out, they don't just circle around the network endlessly, and you get a broadcast storm which basically crashes your network, and it's very bad. So what we're then going to do is reset this, and then we are going to delete the trunk between here and there. So let's go back to here and give it 1 minute. And waiting for the spanning tree to come up. This can take a couple minutes. Okay, so I paused the video briefly, and so we can see that by the green, spanning tree has enabled itself and has come up. So now we're going to go back to simulation mode. We're going to go ahead and forward our packets again, and we'll see they go out. And again, we see that the packet is still able to get around to the PCs that it needs to get to. Okay? So basically what we did is by deleting this link, Spanning Tree automatically picked this link back up, and the network was still able to get the packets from PM1A to PM4B. So let's go ahead and reset this, and let's step down to the full mesh topology, and we'll go ahead and watch it go through. And so we see that a packet is sent out, and it goes to the switch, and it goes across all the open links. So again, you can see here that these are open. These, this, and this link are all closed by spanning tree, but the packet traveled down this link, and this link, and this link to this switch, and these three switches know where they're going to, so then they automatically forward it. And again, you can see this goes up to here and checks it out. And it took less hops to get there. It took less hops for that packet to travel across this network, and gives us greater redundancy. So what we see is that in the full mesh topology, if we go ahead and delete F2 to F3, so let's go here. Oh, gotta go back here. Hold on. And delete and escape. And I will pause it 1 second while we wait for spanning tree to kick in. Alright, so now we can see that this particular trunk has opened up now as we deleted this one. And then if we go ahead and go back here and do our packets again, and we run them out, they now travel down knowing the best way to converge. And that pushes the packet out. And it wouldn't push through this port. Packet Tracer does bug a little bit out doing this, but it wouldn't push through to this way because this is actually dead. This line is considered disconnected. It would push it out this way, and then of course it eventually goes from here to here across to here instead of down through this particular line. So again, you can see we lost this link. So let's say this switch port went bad on this switch. This switch is still able to get over to here and doesn't cause any problems in our network. So our network's still up, and that way when we come in on Monday, we can get on and look, and we'll see that yes, the switch port went down, yes, things did happen, and now we can go fix it. But our network didn't go down, so we were able to stay up. So now we'll take a quick look at the star topology. So if we look at the star topology, we'll see the packets begin at SB4, and as we forward them out, they go out, and the computers realize where they're going, and again they forward again, and then as they get forwarded out, they get forwarded out to the computers. So what happens though is, let's say PC4 is trying to get to PC2. So what we're going to do real quick is we're going to delete that particular set there, reset our simulation, and send our packets out again. So see what happens? Our packets are lost. They can't get, so star 2, so these two PCs are completely cut off from the network. There's no way for them to get to the network. So if we have a business sensitive server sitting here that runs our company's website that all of our income comes through in our web business. Star 2 now can no longer get to the internet because this one port on this one switch went down. We're out of business. We're no longer making money, and we're losing money for the company. It looks very bad, and management gets very angry. So this has been a not so brief overview of the partial mesh topology, the full mesh topology, and the star topology, and how the different designs can affect your network and what considerations you would want to use them in on your network. Thank you for watching.